Okay, according to the famous TV critic, I'm not going to go on with that sentence because everybody's going to lose it. We're talking about using absolute value in equations and inequalities. So, absolute value. What do we know about absolute value? It's the distance from zero on a number line. I mean, that's the easy way to look at it because it's a physical space, right? So let's look at one like, choose 4. So we're looking at absolute value in equations and inequalities. And this is algebra, and this is what I've been looking forward to. The date is 12/12/12.
Hey, everybody make a wish.
Do it at noon, that's 6th period. All right, so problem 4 is 20 minus 7x equals 8. So our first question is, so what about absolute value? So what's different? So the first thing that's different, what do you know about absolute value? You know, the absolute value of 3. The absolute value of 3, it's either 3, so if you had the absolute value of 3 equals 3, the absolute value of negative 3 also equals 3, right? We're all on the same page there, right? So, this value could be either 8 or, this value could either be equal to 8 or what else could it be equal to? Negative 8, right? So, you actually have to do 2 calculations with absolute value. When you pull it out of the absolute value figure, watch. 20 minus 7x equals 8. Or 20 minus 7x equals negative 8. Because it could be either, couldn't it? Yeah. Use the same guideline we just saw here. The absolute value of 3 is 3, and the absolute value of negative 3 is also 3, because they're both 3 spaces from 0 on the number line. So when you have an absolute value equation, you get the absolute value on one side of the equal sign, or the inequality sign, and you get whatever it is on the other side, and set it equal to both the positive and the negative, and run it twice. So then all we do is the math. So first we want to isolate the variable expression, and you can do it one at a time, or you can do it at the same time. It doesn't matter. What are we going to add to both sides? Negative 20. Right, 12. Negative 20, right? You're going to do it to both sides. Doesn't matter if you do it at the same time or different time. Negative 7x equals negative 12, and negative 7x equals negative 28. Then you're going to isolate the variable. So negative 7, divide everything by negative 7, and it's an equal, so yeah, we're flipping the sign, but it doesn't look any different. X equals 12 sevenths. X equals 4. And 12 sevenths is the same as 1 and 5 sevenths. So x is equal to 1 and 5 sevenths and 4. So if you look at your answer sheet down here, WE says 1 and 5 sevenths and 4. That's why you have 2 answers. I'm sorry, did you have a question? No. That's why you have 2 answers here, 1 and 5 sevenths and 4. WE. So what is it about absolute value? What is it about absolute value? You solve for both positive and negative value. I'm sorry. So we have to solve for positive and negative value. Okay? So what happens with an inequality? And I'm going to do one like, let's do one like 16, which looks like really weird because it's got a couple of different things going on. Absolute value of 7y plus 14 minus 5 is less than 30. Everybody with me so far?
Yeah.
Yeah.
Okay. Remember how I said get the absolute value alone on one side of the equation. So first get absolute value alone. So we're going to add 5 to both sides before we isolate the absolute value. Okay? So we still have the absolute value of 7y plus 14, and then it's less than, because when we add or subtract, it doesn't matter. Leave the sign alone, is less than 35. So far, so good? Because now you've got the absolute value alone, now you're going to get your two equations. Get your two inequalities in this situation. So you're going to have 7y plus 14 is less than 35. Now here's the trick. Excuse us, you don't want to miss this. With an inequality, 7y plus 14, and we're going to make it to negative 35. We just flipped a sign, didn't we? So what do you think we have to do? Flip the sign. If we make it greater than or less than, and we make it to negative 35, we're going to have to change the sign at the same time. So if we change it to negative, we also have to flip it. You see why? Didn't we bounce it across the number line like we talked about yesterday? So we're going to have to, when we do our second problem, so in creating an inequality, let's call it opposite. Flip the inequality sign. That make sense? Because you're bouncing across 0. Then you just solve. Put negative 14 on each side. 7y is less than 21. Divide both sides by 7. Y is less than 3. Let's do this one. Negative 14, negative 14. 7y is greater than negative 49. Divide by 7, divide by 7. Y is greater than negative 7. How would you graph that? So y is less than 3 and y is greater than negative 7. Because sometimes we have to graph these. So there's our, and here's 0. What was it? Y is less than 3. So here's 3. It's less than. It doesn't include 3, right? So there's a circle around our 3. And it's greater than, that's negative 3. 1, 2, 3. That's negative 6. And it's greater than -7, so there's a circle around the -7. This is what an absolute value will look like if it's an inequality. It'll be the distance between 2 points, or it can also be the ends of the 2 parts of the number line. Questions? It's just running more numbers. A lot more practice for equalities and inequalities. You see why we have to flip the sign here? That's the hard part, is remembering to flip the sign on an absolute value. Enough steps for you? If you can do these, you can do anything.